2/4 times 2 to the second power. Give me a second as I try to get the right pen. Oh, and we'll use the brush. We'll use maybe the mark. Yeah, this is fine. All right. So question number 1 is 2 to the 4th power. I know it's a messed up 2 times 2 to the 2nd power. What we're looking for is to see if the whole numbers are the same. As you can see, they're the same. We have 2 and 2. Since they're the same, all we have to do is simply put the 2 and add the 2 exponents. We just have to add these 2 exponents. Alright, you only do that when you have a multiplication problem as seen here. So 4 plus 2 is 6. So the answer is 2 to the 6th power. Alright, and you could figure that out on your calculator, which I would like to see you to work out. And that's just basically 2 times 2 times 2 times 2 times 2 times 2, right? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. So the answer is 2 to the 6th power equals 64. Alright, not complicated at all, rather simple. Now the next problem is a little bit different, but same philosophy applied. So question number 2 is 5 to the 2nd power divide by 5 to the 3rd. So with multiplication, we add the exponents. With division, what's the opposite of adding? Subtracting. So we have to just subtract 2 minus 3. And 2 minus 3 gives us a negative 1. 5 to the negative 1st exponent, right? Or if I asked for you to write as a positive, you write this. 1 over 5 to the 1st power. All right? Either answer is suffice. This is the way to write it properly. And if I were to ask you to write as a positive, this is how you would write a negative exponent as a positive. Alrighty? Next. So question number 3. Question number 3 is, once again, 1 over 2 to the 2nd power times 1 over 2 to the 3rd power. Interesting. Well, let's once again, same rules apply. We have this and this are the same, so the 2's are the same, so that's perfect. So all we have to do is add the exponents. 2 plus 3 is 5, so it's 1 over 2 to the 5th power, or if I were to ask you to write as a negative exponent, it would be 2 to the negative 5th. Alright, remember. Alright, that's easy. Easy goes. So I'll skip number 4, so that's repetitive. Let's do 5. So 5, we have 1 over 5 to the 3rd power. But we have to multiply it by itself 4 times. Nothing to be worried about. What we do in this situation, well, let's use an example. If I were to say 5 to the 3rd power, and I have this in parentheses, what do? What we do is simply multiply these two together. We don't add them, we multiply. It would be 5 to the 12th power. Likewise, in this scenario, same rules apply, except we have a fraction. It will be 5 to the 12th power. And if I were to ask you to write as a negative exponent, it would be 5 to the negative 12th power. All right? Very good. Now for number 6, we have 1 over 3 to the 9th power times 0. Interesting. Well, anything to the 0th power is 1. So the answer will be simply 1. Alright, in this case 1 over 1, which is 1. Alright, so that completes that section. Now let's go on to combining like terms. So for number 7 we have 3x plus 5x. Well, 3x, 5x, they are similar terms. They both have 1x. So all we have to do is just add the coefficients, 3 plus 5, which gives us 8, and carry on the x, 8x. Nothing hard about that. What does get a little bit harder is number 8. With number 8, we have 3x plus 4y minus 5x. So before we can even solve that equals, before we can solve it, we have to figure out what are like terms. What 3x and negative 5x are like terms, and plus 4y is a different term, right? Because this is y and the other is x. So what is 3x plus 5x? Same rules, we just add the coefficients. 3 minus 5 is what? 3 minus 5 is negative 2x. And then there's nothing to add to the 4y, so we just write down the 4y. And that is the answer for this equation. Alright, so let's skip down to number 12. So number 12 is a little bit long, bear with me. We have, well, instead of me writing it, well, let's see, maybe I can just magnify this particular problem. There we go. No, that doesn't work. I'll just rewrite it. So we have the problem 2x squared y plus xy squared plus 4x squared yz minus 3xyz. So we have to figure out what are similar. Well, maybe I can color code it, make it easier for us. So x squared y, well, this is 2x squared y, and I do not see another x, and I do not see another xy squared. So we'll just leave that. Now we have this xy squared, and I do not see another xy squared. Alright, well, that's making it complicated. Let's see. Another color. 4xyz. Well, I don't see another one, so that's unique in itself. And what about the last one? We'll make that gray. And 3xyz. Wow, look at that. So we have an x squared y. There's no other x squared y. We have xy squared, but there's no other xy squared. We have a 4 squared yz, and there's nothing to add. And we have a xyz. Wow, so for number 12, there's nothing to change. The answer stays the same. Well, look at that. That is something very interesting. For number 11, though, I know we're working backwards. For number 11, though, let's work that together. I'll help you out. Number 11, I think, is a little bit different. We have 8x cubed minus x squared plus x cubed plus 4x cubed. Oh, this is getting complicated. Cubed minus x squared plus 6x cubed. Alright, that should be more interesting for us. Alright, let's look at x cubed. This is an x cubed. Well, let's circle. Well, we'll circle them. This is x cubed. This is an x cubed. Oh, this is also an x cubed. and this is an x cubed. And what we're left with is, we'll box these. We're left with x squares. I'm left with x squared. Alright, now let's solve it. Let's worry about the x cubes. 8, so we have 8x cubed plus 1x cubed, which makes it a 9x cubed. 9x cubed plus 6x cubed makes it a 15x cubed. Alright, remember, x cubed is the same thing as saying 1x cubed. Alright, it's 1 understood. Next is the x squares. We have minus x squared and a minus x squared. Same thing understood. We have basically it's 1 and 1 understood. So that becomes minus 2x squared. And that is the answer. Alright. So I think that's enough going over the common like terms. So now let's worry about the next which is using formulas. So the first formula given is is F, which is Fahrenheit, temperature. Fahrenheit equals 9/5 Celsius plus 32. 23, excuse me, plus 32. So we need to figure out what is Fahrenheit. So the question given is 23 Celsius is what in Fahrenheit? Well, it's not hard because all we have to do is plug it in. 23 is C, right? So F equals 9.5. It's easier to me to work with decimals, so I'll convert it to 1.5 times C, which is 23, plus 32. Alright, you want to do the multiplication part first, which is 1.8 times 23, which is, well, we can work it out. 23 times 1.8, 8 times 3 is 24, 2 times 8 is 16, that's 14, and then that becomes 23, and we have 4, 7, and 3, and we have our decimal place which belongs here, which is 37.4, so 37.4 plus 32. Alright, and then when we add them together, we get 4.96, 69.4 is the answer. Now, if you want to maintain it as a fraction, which you're more than welcome to do, which is a little bit harder, you have 9/5 times 23/1 plus 32 in the end. That's harder because you have to multiply 9 times 23, 9 times 23, which is something. I'm not going to work it out with you, and then divide by 5. Once you get that answer, you add it to 32, and that's the answer for Fahrenheit. You could do it that way too, but I prefer just changing the 9/5 to 1.8. Now, volume. Volume is easy. So the problem given is, the formula given is V equals length times width times height. And I drew a picture of a container there to help you visualize it. But so V, volume, equals length times width times height. Alright, so for the formula, or for the question given, we have length, which is 4, we have width, which is 2, and we have height, which is 5. So all we have to do is multiply them together. Right, 4 times 2 is 8, 8 times 5 is 40, V equals 40. Look at that, done. Next is word sentences. Now this may throw you off a little bit, and I don't really want to go over this too much, but I'll go over one of them together. The difference of a number and 10 is 37. So we're given the sum, which is 37. It says a difference of a number is a number and 10. The difference of a number and 10 is 37. So basically 10 minus x gives you 37. So I want you to tell me what that unknown is, and to solve the problem. So we could rewrite it as this, maybe x minus 10, which may be a little bit easier for us to visualize. So we add 10 to both sides, and the answer we get is 47 equals x. So the answer is, or that unknown number is 47. All right. There's a little bit of everything in here. Now let's look at this. Let's look at number 15. If 23 is added to 4 times a number, 4x, 4 times a number, the result is, or the answer is 143. All right, so there we go. So that's easy. We subtract 23 from both sides. Let's cross this out. We're left with 4x equals 120, right? We divide, well, I shouldn't be skipping steps, all right? Divide each side by 4. And x equals, after we simplify it, x equals 30. All right. Now on to page 2. So page 2, the first, number 17, is using properties of equality. So all I want you to do is solve simply. We did already example of 17. We already did kind of example of 19. Let's do 20. 20 is a little bit different. We have x over 5 equals 21. So what's the reciprocal of x over 5? 5 over 1. What we do on this side, we must do to the other side. Let's cross cancel. X equals 21 times 5. Once we solve it, x equals 105. All right, not hard. Next is another word problem. Oh well, let's do number 24 together. The sum of 5 times another and 2 times the number is 161. Find the number. The sum of 5 times a number, so 5x is the answer, and 2 times the sum of 5 times a number and 2 times a number is 161. There we go. 5 times a number and 2 times the number. When this is the word sum means addition. All right. So the sum of 2 times a number, 5 times a number, and 2 times the number is 161. So 5x plus 2x is 7x. 7x equals 161. Then you have to divide 7 into each number to figure out what it is. We could do that here. I'll work that with you. 7 goes into 16, 2 times 21, which is 3. So the answer, x equals 23. All right, fantastic. You can do the rest on your by yourselves there. Let's look at, I'll skip 23. Let's go to 24. So we have 3 times x minus 4 parentheses equals 4 times x minus 6. Alright, we have to use the distribution property, 3 times x and 3 times 4. 3 times x is 3x. 3 times negative 4 is negative 12 equals, same thing, distribution property because of the parentheses, 4 times x, which is 4x. 4 times negative 6, which is negative 24. Then we got to isolate all the x's on one side. So I'll put all the x's on this side. Alright. By doing that, I'm subtracting 4 from this side. It doesn't matter what side. I'm subtract 4 from this side. This is cross out. Then you're left with negative 1x minus 12 equals negative 24. And then I'll get rid of the 20. I'll put the 12 onto that side. So I'll add the opposite of negative 12, which is plus 12 on this side, and plus 12 on this side. If this crosses out, I'm left with negative 1x equals negative 12. And because they're both negatives, they drop out, so we're left with x equals 12. Alright, that's how you would do that. Let's do number 26 together. Number 26 may be a little confusing for you all because there's an absolute value. But don't let the absolute value get you worried. So we have the absolute value of 2x plus 5 equals 11. Now remember with absolute value, whatever is outside the brackets is, you have to write the problem twice. So it'll be 2x plus 5 equals 11, or, because the brackets, 2x plus 5, and what's outside the brackets is 11, so that becomes a negative 11. And then you work the problem out that way. So I'm just jumping. 2x equals, I'm subtracting 5 from both sides, equals 11 minus 5, which is 6, or 2x equals, subtracting 5 from both sides, 16, negative 16. So x equals 3 after I divide 2 on both sides, or x equals negative 8. Alright, so this is your answer, x equals 3 or x equals negative 8. That's how you go about in solving for that. Next is clearing the fraction section. That is a little bit tricky. I guess I have no other choice but maybe to go through each one with you quickly. And maybe I'll go ahead and do that. My hands are beginning to hurt. Alright. We have 2x plus 5 over 3 equals 7. So we need to get rid of that denominator, which is that 3. Alright, we need to get rid of that 3. So the opposite of 3 or 1 over of this type of 3, right? This is the same thing as this. So the opposite of 1 over 3 is 3 over 1. Alright, so the opposite of that is 3 over 1. So 3 needs to be the numerator. So we'll multiply each side by 3 over 1 on this side and 3 over 1 on this side. When we do that, what happens? This crosses out. Now we're just left with 2x plus 5 equals 7 times 3, which is 21. Subtract 5 from both sides. 2x equals 16. Alright, and then after we divide 2 on both sides, x equals 8. Great, so that wasn't too hard. Let's do Let's do number, I'll help you out. Let's do number 28 together. Number 28 is not hard. We have, well, let me move this a little bit. We have x over 4 plus x, which is the same thing as x over 1, minus 1 over 3 equals 3, which is the same thing as 3 over 1. So what we have to do is look for a common denominator. We have 4, 1, and 3. The best way to do is to multiply. Can 3 go into 4, 4 go into 3? No. But we can multiply them together. 4 times 3 gives us 12. So the common denominator that I'm going to choose is 12. So I'm going to multiply each fraction by 12 over 1. I'll multiply this by 12 over 1. I'm going to multiply this by 12 over 1. I'm going to multiply this by 12 over 1. And I'm going to multiply this. You know what? This is not neat. Let me write this a little bit neat so you can all understand what exactly is transpiring. So x over 4 is the first one. I give some space. X is the next fraction, but x is the same thing as x over 1. Then the next one I'm going to give is 1 over 3 over 3, which is the same thing as 3 over 1. Alright, now let me write this in a different color. So I said 4 can't go into 3, 3 can't go into 4, 1 can go into 3, 1 can go into 4. But our bigger problem is 4 and 3. What we can do to find a common denominator is 12. 12 is the common denominator. So knowing that 112 is can be the common denominator to add them, let's all switch them to having a common denominator. Alrighty? And this will help us answer the question more efficiently. Alright, so let's put a 12 here. 12 goes into 4, or 4 goes into 12 rather 3 times. So we have to put a 3 here. Alright? 3. So it's going to be 3 times x. Alright, so our new fraction is going to be 3 times x. Alright, so we don't need that no more. Next is, how many times does 1 go into 12? 12 times. So our new fraction is going to be 12x. So we can get rid of that. New fraction is 12 here. 3 goes into 12 how many times? 4 times. That's going to be our new fraction, because 4 times 1 is 4. And 1 goes into 12 how many times? 12 times. So it's going to be 12 times 3, which is 12 times 3 is 36. Alright, that is our new fraction. Alright, now all we have to do is add them up. 3x plus 12x is 3x plus 12x is 15x. 15x minus 4x is 9x. Hold on, I just want to make sure I didn't make a mistake. No, that's not an x. So we're just worried about 3x plus 12x, which is 15x over 12. Alright? Minus 4 over 12 equals 36 over 12. What we have to do is add, we need to add 4 half to both sides. And when we add 4 over 12 to both sides, we get 40 over 12. So we get 40 over 12 equals 15x over 12. Alright, everyone with me? Now you could reduce it if you wish. That may be easier. 3 goes into 15 5 times. 3 goes into 12 4 times. Alright, so that became 5 over 12. 4 goes into 12 3 times. I'm picking 4. And 4 goes into 10, 40 10 times. Alright, so we have 10 over 3 equals 5 over 4. And then after doing that, let me scroll down a little bit. Then we can multiply as a proportion, which is where we circle these and we circle this. Right, so we have 5x times 3 is 15x, because we multiplied this 5 times 3, they gave us 15x, equals this 4 times 10, which is 40x, 40. Then we divide each side by 15. And 15 doesn't go into 40 evenly, but after we do the math, it goes into it. Well, 15 goes into 40. Oh, how many times? Maybe 3? 15 times 3? Yeah, 15 times 3 I believe is 35. Minus 5 is 5.0. And I think 15 goes into there about 4 times, so the answer is 3.4. Now that was a lot of work. Now there's another way to do it without doing all that, because doing it that way is very confusing, and even I don't do it that way. So an easier way to do it, which the book did not teach, but I believe is a lot easier, is to go about doing it this way, because that way it takes a lot of diligence. The way I would do it is, let me write this again. We have x over 4 plus x over 1 plus 1/3 equals 3 over 1. Like I said initially, what's same as 4 and 3, the common denominator could be 12. So I'm going to multiply each number by 12. And this is a lot easier. 4 goes into 12 3 times. Well, that can't go into anything. And 3 goes into 12 4 times. Alright, now all we have to do is multiply. 3 times x is 3x. Very good. 12 times x is 12x. 4 times 1 is 4. 12 times 3 is 36. Much easier this way. Forgot the x there. 3 plus 12x is 15x. Right? Equals 36 minus 4. Right? Because we subtract 4 from both sides. 15x equals 36 minus 4 is 32. And then we divide each side by 15. Looks like I made a mistake in the other way, but anyway, do it this way. This is much easier. And then you need to do the math to figure it out. So x will equal 2 point something, like in the other problem. But it's much easier this way. Alright. Next problem. So the next problem, sorry, I was about to sneeze. So in the next problem we have x plus 2. Well, let me just move it over a little bit. We have x plus 2 over 6 minus, make some space, x minus 1 over 3 equals 1 over 9. So 3 can go into 6 and 3 can go into 9. Same thing, looking at the lowest number. Let's look at 6. 6 can't go into 9, neither can 9 go into 6. But what number can they all go into evenly? Would be 18. Because 18 can go into 6, 3 can go into 18, and 9 can go into 18. You could multiply 6 times 9, but the number is too big. So let's try 18. And the easiest way is to multiply each number by 18. Now bear in mind, there are two numbers here. So because there are two numbers in there, we have to put these in parentheses. This will help us from making a mistake. Alright, now we can solve it. I'll use a different color. 6 goes into 18 3 times. 3 goes into 18 6 times. And 9 goes into 18 2 times. Now we can rewrite the problem. So we have 3 times x plus 2, right, minus 6 times x minus 1 equals 2 times 1. Solve it. We get, using the distribution property, 3 times x is 3x, 3 times 2 is 6, minus 6 times x is 6x, 6 times negative 1 is negative 6 still, equals 2 times 1, which is 2. Now we have to group them. 3x minus 6x is negative 3x. 6 minus 6 is 0, so we can just forget that. So negative 3x equals 2. We divide each side by negative 3. This cross cancels. Let's bring this down. X equals negative 3 divided by 2. Put a 0, because we're talking about decimals, the answer is going to be negative. 3 goes into 20 about 6 times. And it keeps on going on and on and on. So the answer is negative 0.6 infinity. Alright. That was a lot of work, but you guys can do it. Next is coins. And that's the last section. So I will go over that with you all, because that's worth a lot of points. So I want to make sure you all can get it right. So bear with me.